there, students. Today we're going to talk about lesson 5-6, which is on adding expressions. You'll notice that I'm just functioning on the whiteboard today because the book pages are having some trouble getting those loaded. So we're just going to go over the try it and example problems together on a whiteboard. So you're still going to want to be in your book and doing this work and the notes in your book. But I will write down the problems so you'll know exactly where we are in those book pages. Before we get to the try it question, go ahead and read through example 1, where it talks to you about adding expressions using your properties, such as the commutative and associative property. And then we will try a similar problem in just a moment with the try it question at the bottom of page 304. All right, so let's take a look at the problem at the bottom of page 304. We're talking about Sophia and Ollie, and they are depositing money. Each of them made deposits that you see there on the graph in your book, and then I've got them also here on the whiteboard page. And what we're looking to do is to combine their deposits to determine the amount of money in their joint account after M months. So let's first take a look at Sophia's deposits. Since Sophia deposited $120 initially and then $150 for each of the months that she makes deposits, the expression that best describes Sophia's deposits are 120 plus 150 times the number of months that she makes those deposits. Next, we're going to take a look at Ollie's deposits. Ollie also makes a $120 initial deposit, but Ollie adds $135 each of the months that he makes deposits. So his expression would be 120 plus 135M. Now what we need to do is combine their amounts of money together to find one expression that describes them both. So if you look at the second row of boxes on your paper there, what you're looking at doing is combining the two initial deposits of $120 apiece plus then each deposit that depends on the number of months that they saved their money to get one single expression, which would describe the total amount that we know they deposited, $240, plus the grand total amount of money that they deposited each of those months, which would be $285M. So there are your boxes in your last and final row, and then each of these boxes that would make up that second row. When you take a look at page 305, you'll notice that example 2 asks you to add expressions that have more than one variable. Remember that you can only add like terms together. So when you have variables that are not alike with each other, then you cannot put those two terms together. Instead, leave the variables separate, as you see there in example 2. Example 3 is just involving more complex expressions. In other words, they're going to throw decimals and fractions at you and ask you to combine those. In the cases that you have here, hopefully you'll find that some of those fractions will have easy to find common denominators, and decimals you can easily use your calculator to combine those like terms. All right, as you try the try-its here at the bottom of page 305, I want you to focus specifically on try-its A, B, and C. And when you come back to check these, we're going to do them one at a time. You'll see me using some color coding to help identify common terms or like terms that we can put together. And then we'll do our final expressions underneath each of these. So go ahead and start on A and pause the video. Come back and replay the video when you're ready to see your answer and check that for part A. All right, notice in part A you had two separate variable terms that cannot be combined. So you just use those two terms in your final expression. Remember, math folks like me, math geeks, like to see the variable terms first in an expression and also with the variables in alphabetical order. So the term with C would come in front of the term with P. It doesn't matter as long as you have the correct sign, positive or negative, in front of those terms. But this is what you should get in your final expression, because the only two parts that you can combine are the two constant terms, the negative 250 and 50 hundredths, plus the 185 and 70 hundredths. All right, and when you're ready, go ahead and pause the video, try letter B, and then come back and check your answer again when you're finished with that. All right, let's take a look at letter B. When you combine your two x terms, you get a negative 1/11 x. They were nice and gave us a common denominator there. Your two y terms actually are exact opposites, a negative 5y and a positive 5y, which means when you put them together, you get 0y, or 0 times anything is 0. So you do not have a y term anymore in your simplified expression. And then your two constant terms, a negative 3 and a positive 5 and 5/10, would make, oops, my mistake, let me correct that. Hold on just a second, please. All right, check that out. And it should be a positive 2 and 5/10. My mistake there. So that is the correct one now showing on your screen. All right, and when you're ready, go ahead and try part C, and then again we'll come back together and check your answer when you're all finished. All right, and go ahead and check your answers to part C. All right, and now I'm going to flip to the next slide, and we're going to do part D. So let's take a look at D. It seems to be more complicated, but really all letter D is just a series of fractions, and you just have to make sure that you get a common denominator where needed. So let's check that one out. All right, so what I notice here immediately is that I do not have a case where I need to get a common denominator for all four of those fractions. Instead, in this one, as I look at what I'm given, I see here is the first variable, and we just need to get a common denominator for a negative 1/6 m plus the 7/10 m. So when we do that, we're just looking for what is the first thing in common with those two. And let's see, we can go to 30ths. So this is going to be negative 5/30 m, and then this is going to be 21/30 m, which means we get a grand total here of 16/30 m, which will need to be simplified, and we get, let's see, 8/15 m. So there's my m term. Now I'm going to switch colors, and we're going to do the other variable, which is the 5t plus the 9t. And we get 14t. And then on our last one, we have a 3/8 plus a 1/4. And luckily, we can use the eighths, and 1/4 is the same as 2/8, so we get 5/8 as our final. So what that means is if I'm going to put these three pieces back together in an expression, I have 8/15 m plus 14t plus 5/8. So although that one seems to be way more complicated because of the fractions, it's really not as bad as it seems. All right, so now as we check in with the work in your book, we're going to try numbers 4 through 7 on page 306. I'm going to let you pause the video while you do that. Remember that when you're adding expressions, you're just doing what we've been doing all along with simplifying, and that is just putting the expressions together. All right, come back and check your answers when you're ready on 4 through 7. All right, go ahead and take a look at your answers for 4, 5, 6, and 7. You might want to pause the video while you're checking those. If there's something that you aren't sure about or something that doesn't make sense, please come see me before you go on to the next slides. All right, I've got about 5 more problems for us to try together. We're going to start on page 307 with numbers 12, 13, and 14. So you may go ahead and try 12, 13, and 14 on page 307. I'll even erase here the page 308 because we're not going to do that yet. Try those 12, 13, and 14 and then come back here when you are finished and check your answers. All right, so let's take a look at your answers for 12, 13, and 14. In problem 12, notice that you had a B term and a 5B term. Remember that the number in front of a variable that stands alone is a 1. So B plus 5B makes a total of 6B, and then your constant is 10, and that just gets added on. In question 13, it did not give you a picture, but it's easiest if you write a picture, if you draw one, and then write each part of that expression along a side of the triangle, as I did here in the picture. So it says that the bottom of the triangle is X. You can see that here. And then it says another side is 1 more than 3 times that bottom side. So 1 more than means to add 1. 3 times the bottom side would be 3x. So 1 plus 3x represents another side. And then the last side is 2 more than the bottom of the triangle. So this is where we add 2 to that bottom of the triangle piece, which is 2 plus x. And then to find the perimeter, you simply add those 3 expressions together. So you have x, which is the bottom side, 1 plus 3x, which is a second side, and 2 plus x, which is the third side. And when you put those together, you put all of your x's. So x plus 3x plus another x makes a total of 5 x's, and then 1 plus 2 makes a total there of 3. So 5x plus 3 would be the expression that represents your perimeter of the triangle. In question 14, they gave you this expression here, 4 plus n plus 7m. And it says that Sarah identifies only the coefficient as 7 and the only constant as 4. And it asks you to identify all the coefficients and constants and then to determine her error. Her coefficients actually are 1 and 7. The constants, she does just have the 1. It is 4. And her error is likely that she forgot that the coefficient on the n variable, even though there's no number there, it just means that there is 1. So she forgot the coefficient of 1 in front of that standalone variable. All right, on page 308, we're only going to do 2 questions here, and I found that these are 2 of the questions that caused some of the most distress when it came time for the Math Excel. So when you try 16 and 19, you might come back and make sure you check your answers, and then you can brief through the other questions that are on this page and just see if there's anything else that you think you need to try on your paper before you get to your Math Excel. And if there is, let me know, and I can certainly provide you with the answers to those other questions before you get into your Math Excel. All right, so pause the video, try 16 and 19, and then come back and check answers. All right, go ahead and take a look at number 16. Number 16 reads, Nina has X coins, so that's the X right here. And then it says Clayton has 5 fewer than 6 times the number of coins that Nina has. So we're going to take 5 away, that's the 5 fewer, then 6 times Nina's coins. So 6 times X is Nina coin. and then take away 5 means 5 fewer. And then when you add these two expressions together to find out the total number of coins they both have, you have x plus 6x minus 5, which means you have a total of 7 x's and then minus 5 coins. All right, then take a look at 19. 19 has two parts to it. Middle school with X students ran a survey to determine the students' favorite activities. The table indicates the number of students who enjoy each activity. It quite frankly doesn't matter what variable you use. They used X, I used S for students, but you certainly could change that. So here is your table from part A. I did not write out the word descriptions, but I did write out the expressions that go in those boxes. So dance is 25 more than 1/10 the number of students. So 1/10 times the students plus 25 is dance. Soccer says 20 fewer than 3/10 of the students. So I need to do 3/10 times S and then minus 20 because 20 fewer means I'm going to take away 20 from that amount. And then I have the baseball, which is 21 more than 1/10 of the students. So I'm going to do 1/10 S plus 21. Then when you look at part B, it just wants a simplified expression to represent the students whose favorite activity is either dance or baseball. So we're going to put dance and baseball together because I want the students who would have picked either of those two. So I have 1/10 S plus 25 for dance plus 1/10 S plus 21 for baseball. And when I put those two together, I get 2/10 S plus 46, and don't forget you need to simplify that fraction, and it is 1/5 S plus 46. If you have questions about this, come see me. Otherwise, your Math Excel for lesson 5-6, adding expressions, is in your Pearson account.